Welcome everyone. This is a live demonstration, a tour of the universe. I'm Brian Autumn and we're going to have some fun tonight. We're going to take a tour of the universe. We're going to start with things that are close to the Earth, and then we're going to finish the night with stuff that's far, far, far away. And so I want to just quickly show you a little bit of a introductory video about where we're coming from here. We're going to see my pictures and videos I take live. This is all live. We're using a telescope that is located across the country. And but along the way here, we're going to be watching the chat, and as people will chat, then I can answer the questions. We're going to have breaks along the way, so I encourage people to chat there. I've been a fanatic watcher of the skies ever since I saw a blood-red lunar eclipse back when I was 12 years old. And so, like a lot of other astronomers, I start with a small telescope and get bigger and bigger and bigger. I love seeing outer space, but I got really hooked on taking pictures of outer space. And so I just started with putting a camera on a tripod and taking pictures of stuff that's close by, meteors and northern lights. And lunar eclipses, solar eclipses are spectacular, but they're rare. Unfortunately, dark backyard skies are also becoming very rare. Light pollution, outdoor lighting is taking away our night sky. People listening to this, most of them can't see the Milky Way from your backyard. The problem is not slowing down at all, so I myself had to take action. I moved my telescope from my backyard here in Michigan all the way across the country to a place called Dark Sky, New Mexico, in the desert southwest. It's close to the Arizona border, not far from Mexico. There's absolutely no light pollution, so when you look up, you feel like you're falling into outer space. Let's take a tour of this telescope ranch with a drone. All the observatories have roofs that roll off on wheels. It's kind of like your garage door. On the left there you can see that's the biggest white roof. That's our observatory. I've got two partners, two more telescopes in addition to mine. And most of the other observatories have 1, 2, and even up to 9 telescopes inside. It's clear there over 300 nights a year. We're at 4,000 feet elevation, so you're looking at a very thin and dry atmosphere. And as we take a tour here, do you see that blue deck with the red telescope up there at the top? That was Clyde Tombaugh's personal telescope, the guy who discovered Pluto. So that's very cool. He lived not too far away. Earlier tonight, I opened the roof, and this is what it looks like when the roof opens up. It just slides kind of like your garage door. Pretty simple. And we need to open that roof because we got to get the heat out of the building. When the heat builds up during the day, and today out there it was in the upper 90s. The West, as you know, has been having very, very hot weather, and so we got to get that heat out. I forgot to open the roof earlier, and so I opened it a little bit late, but it's cooling down pretty well right now. So now we will have more of a live shot of what you're looking at here. In addition to my face, you're seeing the computer that's out there at the telescope. And what we're going to be doing here is taking a look at things through the telescope. And so I'm at the lower right, and at the upper right there, and I'll put my cursor kind of in there, you'll see this is a live picture of the telescope. I have a camera that's focused on the telescope, and it's kind of in the moonlight there, but let me turn it on here. I want to show you what the telescope looks like really, really carefully. Here we go. So what I'm doing now is I'm turning on the infrared night light, and this illuminates the telescope. There you go. Now you can see that it has a one-armed mount. It's a plane wave made in Michigan here, and that's a robotic mount. I control it by just pushing buttons here, and then the telescope is that black tube, and I have a Canon camera inside that that silver shoebox at the top. That silver shoebox is a cooler box because it's hot out there in the desert, and we need to cool it down. So we've got a cooler box on there. I'm going to turn the light off because maybe I'll leave it on. What the heck? The moon is so bright tonight, so it really doesn't make a whole lot of difference if we have the lights on or not, because we're not going to ruin our view too much. So we've got the light on. You can see the telescope working. So what we're going to do here is just point to something. I have got the star chart here. This is the star chart, and this is the control program for the telescope. If I push on something, let's say I push right here on this, that's the North Star, and it'll say Polaris, go to Polaris. Now watch the video on the upper right hand corner. It's a few seconds delay because of being so far away and the way it's set up. So there you go. And you can see the telescope moves, and it moves pretty fast. So I was earlier focusing on a star, that's a star there, but now we're just going to take a picture of the North Star. Let's see what this looks like. There we go. And that's the North Star. And as you can see, there's double lines there. That double lines means my focusing is bad. I got a bad focus here. So if we want to try to fix the focus, what I do here is I turn on the focuser here and I just move it a little bit. Yes, I know focusing is probably the most boring thing that you're going to see tonight, but we do want to have a nice sharp view of what we're looking at. So let's just try to get a little better. What we want to do is merge these doubles into singles. And is that a little better or a little worse? Let's go back to the previous picture, up to the new one. It looks like it went downhill, didn't it? So we're gonna move it 3 steps. Once we get this focus set, it stays focused pretty good for the next for the rest of the session tonight. So, but the problem is there's so much heat, and the telescope will expand in the heat, and then once you open the roof, it contracts because it's cold. Now it's getting better. See, that focus is getting much better. So we'll go 2 more steps. And over the course of the night in the desert, the telescope shrinks, the tube shrinks, and the focus changes. And so I have it set up so I can adjust for the temperature automatically. Okay, that's it. Now, one thing interesting about the North Star is that most people don't know this. Well, everybody says it's the brightest star, isn't it? No, it is not the brightest star. Everybody, I don't know where that came from, but the North Star is a pretty weak little star. Oh, we have a question over here. What is causing the 15-degree line? You know what? That is a fantastic question. I do not know what that diagonal line there is. Sometimes when I get weird lines in the field of view, it's a spider web. So I've actually had a little spider web across my camera area, and it's it's irritating. But what can you do? It's 1,700 miles away. So let's get way down to, and what I'm doing here, I'm not explaining myself well here. We're taking 1 second exposures. The duration is right there, 1, and the ISO is the sensitivity. It's you're basically turning up the sensitivity of the camera. The lowest sensitivity it goes is 100. I'm going to the lowest sensitivity because I really want to be able to show you the double star. So I'm going to zoom in here. I'm zooming in. Oh, there it is. There's the little one, and there's the big one. Okay, there you go. So you can see that Polaris is a double star. It's got a little one that goes around the big one. So that's really all I wanted to show you there. I think what we want to do here is go to another object. So we click back over on the planetarium program. This is the night sky. Right here we're on the North Star. There's the Little Dipper. Okay, here's the Big Dipper, right? And those are the pointer stars. And those two point to the North Star. That's how you find it. Okay, and we've got this right here is Hercules. You can see he's got a club in his hand. He's about to club some animal. I don't know which it was. But we got the Northern Cross right here, which is also the swan. It looks like a swan. There's the head of the swan and the tail. That's the Northern Cross. We have the lyre, the little harp. That's Vega and the little harp. and then we have Altair. And this program also shows this gray circle is the moon. Okay, we'll be seeing that tonight. And we've got Saturn there, Jupiter there, the teapot right here, that's Sagittarius. So this program changes with, it's an actual representation of the sky. It's a perfect representation of the sky, the way it looks right now. So let's look at Vega. Vega is one of our closest neighbors. It's about 25 light years away. And now I'm going to hit go. Watch the video in the upper right. Watch the telescope move on delay here. It's about a 5-second delay. Oop, there it goes. Going back to the camera. We're going to crank it up to, I usually take a lot of pictures at like 1600 ISO, 1600 speed. And let's see if that 15-degree line goes away or stays with us, because like I said, I have no idea what causes that. And I do see it periodically. Seems like 1 out of 100 nights. Now look at, there's no 16-degree line there, but that's a close-up of Vega. If you remember, that is the star that was in the movie Contact with Jodie Foster. She heard from them. So, all right. So we're kind of skipping around, but I'm kind of stalling because we're going to see it. We're going to try to chase a satellite, and it's not ready yet. So we're kind of taking things out of order because I want to show you things that are close to Earth and then further away. But this is we need just another tweak on the focus, I can tell. So what I'm going to do here is hit the focus. I'm going to go a little bit further out. Boom, boom. Go back to a picture. And I have a routine that it'll automatically focus. I don't have that software up and running. But the telescope can be operated automatically. Right now, what I would often do is I'll get things focused. I'll set it up to compensate for the temperature change throughout the night. And I'll set it for tracking. And then I'll go to bed. And so it'll take pictures for 4 hours. I did that just 2 nights ago, and it worked great. So when I get up in the morning, I close the roof, and then I take a look at my pictures. And most of the time, I got a lot of them, and they're great. Sometimes the clouds rolled in, and I got no pictures. But that's what happens. So now we're going to take a look at something that is close by. Very, very close by. So let's take a look. We're going to now look at a live view of the moon. So this is a live shot of the moon. And this is we can zoom in. And you can see that things are boiling. That's our atmosphere. Okay. The desert was hot today. The heat from the ground is now escaping up into the sky and leaking into space. And so there's just a whole lot of turbulence up there. And you can see that turbulence as the moon kind of wobbles there. But that is normal. I want to tell you that some of the color here is due to my camera is a little more sensitive to red. So everything's take on a little bit of a pink view with my camera. But it's pinker than normal because of that smoke that's going on out there. So I just want to tell you that this is a little bit pinker than normal because of the smoke that we're getting out there. Let's take a look down here at this is the really great crater down there. It's probably this crater down here is called Plato. It's very flat. Take a look at it. It's got a very flat bottom, and that means that lava filled it in because it used to be pretty full of rubble when the space rock smashed it millions of years ago. But now it's kind of smooth, and it also fast. So that's Plato right here, and somebody will probably chat and ask, how big is that? I think it's about 50 miles. Maybe 75 miles across that. That is a big crater. Very old. And this right here is Alpine Valley. It's kind of like the moon's Grand Canyon. It's a valley, and it's pretty fascinating that it's you can see it. But you can see that it's very turbulent tonight. So if we were looking, this is the view. You know, you looks like if you were looking through the telescope, this is exactly what you would see. So the moon is close by us, and the light that left the moon took only 1 second to get here. 1 second. So that's what the interesting thing about the moon is. It's close to us. Now, if we want to take a picture of the moon, we can set it to like a 1/1600th of a second. Let's try that. A 1/1600th of a second. Now, instead of video, we've switched to still photography. I don't like to do video too long. It heats up the camera. Wow, look at that. We've really zoomed in there. All right, this is the, I think it's called the Apennines. It's a big mountain range on the moon. You can see that. There you go. Now you got Plato and the Alpine Valley there. I'll tell you that where Apollo 11 is right here. The first men on the moon was right there. The moon is just after half moon, or first quarter. You know, what's interesting is that we have these dark areas on the moon. That's lava flows. All these seas, those are lava flows. And once we got probes out there and looked at the other side of the moon, the other side that we never see, it doesn't have any of these. It's just a craters as far as you can see. Just a sea of craters. No dark, smooth areas. And so Alex asks, how far can we zoom in? Well, as far as we are limited by two things to zoom in here. How well did I focus, which was pretty good, and how steady is the sky? Okay, I'm up to 700%. I'm up to 800% here. So remember, things were boiling out there. That sky is very unsteady tonight. It's not a good night for high power viewing tonight, and so there you go. That's about as much as we can zoom in, but it's kind of fun to zoom in on stuff, and so that's a good question. And then Samara asks what software I'm using, and this software I'm using to control the Canon camera is called Backyard EOS. And the gentleman who designed it is from French Canada, and he's also got a product called Backyard Nikon, which you can imagine goes with Nikons. This one goes with Canons. It's a wonderful program. It's fantastic. It's like $30 or $40. The customer support is fantastic. I just love it, and it's easy to use. It's fun to use, and it does a great job. It really does, as you can see, and you can zoom in, right? I could even go full screen. Watch this. Let's go full screen here. Boom. That's full screen. And I can go like that. So this is called Backyard EOS. It's been around for several years. Oh, probably 9 years now. And it's a fun program. It's really great. So it is time to try to see. I'm not guaranteeing anything, but I'm going to try to chase a satellite across the sky. Now watch the video in the upper right. Watch the telescope. There's a satellite. This is a rocket booster that was launched a few years ago. It's an Atlas Centaur rocket booster. It is whipping across space, or the sky right now, and we are going to try to catch up to it. All right, there it is right there. It's not real bright. Woo! There it is. Let's get it. You know, it's a rocket. It's a leftover shell of a rocket that was used back when they were launching something. And you know, we have a lot of spent space junk. This is a big piece of space junk, and you can see that we are not tracking perfectly. It's not we can't do a perfect job, but let's try it again here. But it's cool that, and watch the telescope. I mean, we're really moving at high speed here. There it is, And if it was a darker night, you'd see stars be whipping by at high speed here. But as it gets higher in the sky, it's going to get brighter and brighter. And you can see the telescope going up. I've been told that these telescopes can, they're used to track even faster objects that are whipping by. It will accelerate. You can see it's rotating faster and faster. Now the camera, the telescope, and the mount are not perfect, so it's drifting up higher, up to the left there. Now a couple nights ago, I used this technology to get a video of the International Space Station, and if you look at my YouTube channel, you'll see a video of that called "Chasing the ISS," and from this view right here, you can see the solar panels and the details on top of the space station. We'll do one last reposition here. And we'll go up to high power. Boom. 5x, 10x. All right. So it is, it's reached, look at, almost overhead, isn't it? Right about overhead. And this is Atlas Centaur 5. And it was launched a few years ago. And it's just a big piece of space junk just up there orbiting Earth. It's one of the thousands and thousands and thousands of things. But what I wanted to show you about this is that now we're looking at something that its light took only a millisecond to get here, because it's real close to us. So this is the closest thing in our tour of the universe tonight. The closest thing we're going to see is this satellite, which is just orbiting Earth at a couple hundred miles up. Does it look like the telescope is not moving anymore? Looks like the video is frozen. Well, that's interesting. Well, anyhow, we're pretty much done here. So what I'm going to do here is I'm going to hit stop. Telescope is stopped. And we will continue our tour of the universe by going something further out. So what's further out than the satellites and further out than the moon? That's the planets. So one of the closer of the planets we're going to see tonight is Jupiter. Let's take a look at Jupiter. We're going to turn on the video. Jupiter is to the south. Put on the video. And this is the great planet Jupiter. Now, this is the view through the telescope, and you can see what's interesting is that we got Jupiter, but what are those three dots on the right? Well, those are Jupiter's moons. Probably Callisto, Ganymede, and Io is gone. Ganymede, Callisto, and Europa. But you can see this one on the right is a smaller one than these two in diameter. But these are huge moons. They're just as big or bigger than our moon. So let's see if we can take a picture of Jupiter that shows the detail. I want to be able to show you the detail, the cloud bands on Jupiter. So if we take a 125th of a second, this is a short exposure. Let's just take that. And if you look at the video of the telescope, you can now see the silver shoebox. The silver shoebox contains the cooler that surrounds the camera. Well, that's not a very good picture. Let's zoom out. Oh, there we go. Oh, somebody, Samir asked, is it just me or is that rocket casing rotating? Well, certainly that video of the rocket, if I had not overexposed it, you might have been able to see that it was a tiny little stick rotating, because that's what a rocket booster is, right? It's a tiny little stick rotating. So that's a great question. Absolutely. Let's crank down the exposure here. I really want to show you the really cool cloud bands. So we're going to zoom in here. Oh, what's that? This dot here is not one of its moons. That's a star. Okay, now you're starting to see some of the the cloud bands on the planet. Perhaps we were seeing the red spot on the left there. See, it's a little dark on the left, and it's not a great night for planetary pictures. We can tell that. I'm wondering if one more. I'll try one more picture, and then we'll move on. But Jupiter has these horizontal cloud bands, which are really weird. And it's because Jupiter rotates so fast, it rips its clouds into a horizontal. It stretches them sideways. Because Jupiter, even though it's monstrous and many times bigger than the Earth, it rotates in 9 hours. How many hours does it take for us to rotate? 24. So it is really whipping along, and those clouds are ripped into lines. So that's Jupiter. What's the next planet out? Saturn. We hit go to. We're going to Saturn. Saturn's right close by. If it's clear where you're at right now, go and look outside and see Jupiter, and then you can see Saturn right next to the moon. Moon is right next to the moon. So, and we're in the desert for this, so everything here is it's 2 hours 2 hour time lag from Michigan. All right, we're keeping the fast exposure. All right, now that's a little weak. Okay, let's turn down the let's have a longer exposure. Saturn is one object where at Astronomy at the Beach, when people see this through a telescope, they can't believe their eyes. They can't believe you can actually see it, and that's, you can see the rings that good, or even better with Astronomy at the Beach. And so I urge everyone to come next year. Hopefully we'll be able to be in person, and you'll be able to actually look through a telescope and you'll see Saturn, and it's way cool, and it looks much better than this through a good telescope. So you got to come next year and see Saturn. This dot here is probably Titan. Titan is the largest moon in our solar system. It is quite a bit bigger than our moon. I believe it's nearly the size of the Earth, but it's certainly a big moon. And if I were to take, let's just see how many moons can we see. How many moons does Saturn have? Okay, so if we crank it up to, let's say a 4-second exposure, all right, we're going to way blow out Saturn, right? I mean, Saturn's going to be way overexposed, but we're going to see all of its moons, because how many moons does Saturn have? I mean, it's like over 100, 200. I mean, what's a moon? You know, if it's something a softball size, is that a moon? But there's a lot. So, all right, we've blown out Saturn, but look at all the moons. Some of these are stars, but I would say most of these are moons. Iapetus and Tethys and Dione and Hyperion and Titan. So really, and some of them are pretty far out. So some of these outer dots here could be moons as well. So people are always asking me, okay, yeah, what software would I use to try to figure out where the moons are, or where the red spot is tonight? And there's many apps for your phone. I really would urge people to get an app to show the night sky on their phone. The best one is Sky Safari. Highly recommend Sky Safari. You don't have to get the Pro version, which is like $30, which is really awesome, which will control your telescope, just like we're doing right here. It'll do that. But you can get the $5 version, and it'll show you all this stuff in real time. So highly recommend Sky Safari. Got to get that. So we're trying to take a tour of the universe here and trying to go close to far. And we've gone from Jupiter to Saturn, and the light that we took a picture of here, the light left Saturn over an hour ago. And light travels pretty fast, doesn't it? I mean, if you turn on a flashlight, it gets across the room pretty fast. But the speed of light took 80 minutes to get from here, get from Saturn to here, which is pretty amazing. So now we have toured the solar system, whatever we're going to be able to see tonight. I don't think Neptune is high enough. That's the blue dot right there. Nope, not quite. It's not clearing the roof. I got a roof over on this side, and so we can't see Neptune yet. It's pretty boring otherwise. So now let's leave our solar system, and let's go out into we're going to answer a question here. John asks, can we see the Mars tonight? Well, what's that red dot right there? Click on it. It says Mars. Altitude 2 degrees. That means Mars has just come up in the desert. Now here in Michigan right now, Mars is higher. If we had a telescope right now tonight, if you went up to look right now in the east, Mars would be up this way, up higher, and we could use a telescope to see Mars right now in Michigan. But since we're out way in the western part of the United States, it takes a couple hours for this same stuff to happen. So maybe at the end of my presentation we might be able to see Mars, but we might see some detail on it. And one thing that I do want to say is that the boiling and all that, the atmosphere being very unstable, as we saw with the moon, that gets better and better as the night wears on usually. And so perhaps it'll be better at the end. We can give Mars a shot at the end of the night. But as I said, unfortunately, the roof of the observatory cuts off the lowest stuff right there. So that's an unfortunate thing. But we might give it a shot. So let's leave the solar system for now. Let's go off in our rocket ship into the Milky Way. That's our home galaxy. And let's find out how our stars born. What causes stars to be born? Let's go to a place where stars are born, and I want to show we want to show some objects here. So now what we've got here is these are the green circles are cool objects in the sky. Okay, we're going to go down here by the teapot, and we're going to click on this circle right, this green circle right there. It's called the Lagoon Nebula. So now we're going to head down to the Lagoon Nebula. And what's great about the Lagoon Nebula is that this is where stars are born. So we're going to go back in time. We're going to figure out how stars are born. This is a cloud of gas where stars are forming as we speak. And so in our tour of the universe, we want to start to show how are things formed. So this shows how stars are formed. They're formed out of gas that slowly compresses and spins and goes around, and then after a little bit of time, then the fusion happens. The star turns on, gets super bright, and this is one of those places. The camera is very sensitive to red because a lot of the cool stuff in the sky is red, because red is activated hydrogen, excited hydrogen, and that is one of the biggest is the biggest element in the universe, and it's where stars are being formed out of this glowing hydrogen gas bubble. So that's what we're going to look at right now. Let's go back here, zoom back, and what we've got here is too much exposure. We've got too much exposure. Now let's see if we can play with the histogram. I'm not guaranteeing. Nope. That's not going to work. All right. I think one of our issues here is that we're trying to do something right next to the moon, and that moon is so bright. You know that us astronomers, we don't love the moon. We don't really like the moon at all. We curse the moon. It's not good. The moon is bad. We hate the moon. But we need it, so we're willing to have it. But it ruins the view of all this stuff out there in deep space. So those nights where the moon is not out are the best nights. There we go. Now we got a little bit better. This is much better. So there we go. This is a cloud of hydrogen gas where stars are being formed right now, and there's dust and these dark splotches are where protostars are being born, kind of like in little cocoons. This little cluster here, those are stars that were recently born. They're very blue, and they're young. They call it the Lagoon Nebula because there's a dark lane here in it, kind of like a river, and so it's the bright red is glowing hydrogen gas, and the dark stuff is dust. And the dust is dark, and it's a dark cloud, kind of like smoke, right? And the smoke keeps us from seeing what's behind. And this is also called Messier number 8. And Charles Messier was a French astronomer, and he cataloged a lot of the objects that now we know as the kind of the greatest objects, the top 100 we call it. And so this is number 8. There's no ranking, or there's no the 8 means nothing deliberately, but he cataloged them. This was the 8th one in his catalog, and this is the Lagoon Nebula. It's a birthplace of stars. And what I want to do next is go to another birthplace of stars, which is close by. It's called the Trifid. Click there, goes to that. And maybe this is time to, let's turn off the camera. So this is the camera, this is the telescope. You can see that I have a plastic cover around the telescope. It's a wind shroud. It keeps the wind out because the telescope is kind of subject to gusty winds. You know, it gets windy there in the desert, and so we need to keep the wind off. So that's how I do it. So now the telescope is kind of invisible, but yeah, I think it'll improve our view. So I'm going to take this a 12-second exposure of the Trifid. And what's neat about the Trifid is this is an object that is where stars are born, but it contains a little more color and other colors. And this picture was on the deck of the Enterprise in the first year of Star Trek. So Captain Kirk had it over his head in a few episodes. So you can see why they call it the Trifid, because there's 3 dark smoky dust lanes there that split up this cloud of red gas, and you can see there's stars right here in the middle that have recently been born out of that gas, and that is right next to another glowing cloud right here. Can you see that it's kind of bluish? Okay, so that is that's the Trifid Nebula. I'm going to crank up the sensitivity for our next object. So what we just saw was 2 places where stars are being born. Let's try one more. The Swan. It's also called the check mark or the Omega because of what it looks like, and we'll ask you what you see in it. Let's do a 25-second exposure. And this is the 3rd and final of the star-forming regions. I call them stellar nurseries. It's where stars are being born, and it's a good place to start on a tour of the universe. And we got a request for the Pillars of Creation M16. Okay, we'll do that too. Because that's a famous Hubble shot, and we'll try to show you what Hubble was showing. All right. Now, to me, I can see the swan. You see the swan swimming to the left. There's the head. There's the body. I'm wondering if I can get a little bit better definition there. Yeah, we're getting close to the full moon, or the moon here, so that's why it's kind of tough to get these pictures. But you get the idea. It's clouds of gas. All right, the last stellar formation is going to be the Pillars of Creation. I'm going to go up to that. Let's take some pictures there. when the moon is so bright, it tends to wash out things, and it makes it hard. Um, if people have a camera that is black and white, mine's color. But if I had a black and white camera, I could put a hydrogen alpha filter, which is deep, 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 deep red filter over that camera, and I could take picture of these red things even in the full moon. And that's a great idea. And there we got a lot of people in Michigan who do great pictures by doing exactly that. Okay, well, it's kind of hard to see. The pillars are right here. See the fingers? There's 3 fingers there, and that's the pillars of creation. Yeah, I wish I could do better on there for you. There, now we're doing better. We're getting good at this. I'm playing with this histogram here. You can see in the upper right, and basically I'm trying to filter out that moonlight and just give you the gas. But you can see there's 3 fingers there and a big finger there, and there are stars being born, especially at the end of the fingers. That was the pillars of creation that the Hubble took. And this is also called the Eagle Nebula. I guess we got to really zoom out to see the eagle. I think the wings go this way, and we're looking at the head of it, I think. You know, you got to have a lot of imagination here. But interestingly, oftentimes when there is a cloud of gas, that red gas, the stellar nursery, there's baby stars, and these are baby stars right here. They're young, hot, and red. I'm sorry, blue. Young stars are blue. So now I've given you 4 stellar birthplaces. But next step is what happens if stars are born, and what if they're born and they live together in a group? And a group of stars is a cluster. So let's take a look at a star cluster. And while we're doing this, I'll show you the tracking on the. This is the tracking on the telescope. This is a live shot of how accurate the telescope is tracking. The red line is right ascension, or left-right in the sky, and the blue is declination, or up-down. And this just shows you how well you're doing. When there's a lot of wind, you'll see this thing go crazy. It'll go up and down as it tries to correct for the wind. My camera is a 1 arc-second camera, meaning that anything in this zone right here, I don't see any air at all. So we're pretty darn good. But if we get more above this line maybe, or below this line, then I'm starting to have a degradation of my pictures. But this is just fascinating, and it's amazing technology that this mount here that's made in Michigan is able to perform so well. I don't do any auto guiding for my pictures, which is fantastic. And well, there's a question from Alex about other telescopes I used to have back when I lived in Cincinnati. And what's interesting is that the telescope out there is nothing fancy. That telescope is a pretty average telescope, very much average to telescopes I used to have years ago. It's a 10-inch mirror, and it's a 5-foot long tube. Nothing too huge there. What's fancy is what you're looking at. This mount, the white one-arm mount, the robotic mount is really the most important component here because it's doing the pointing. The optics are nice, but you need to point. And the ability to be able to do this from 1,500 miles away is critical to have a good mount. So when people are getting into astrophotography, the mount is everything. Very, very important. Kind of like if you're an audiophile. Speakers. Spend the money on speakers. Okay? You can spend money on electronics later. Same thing here. Optics, not important. Telescope, mount, important. Even camera doesn't make that much difference. So it's a good question. So we've got a picture of our cluster. There it is. This is called the wild duck cluster. It's several hundred stars all born together, live together. They do drift apart over time as they get older. And it's called the wild duck because a guy back in the 1800s with a crappy telescope thought he saw a flock of ducks in there. I do not see a flock of ducks. Now, if we go way out, if we zoom out, he did say that looked like he saw a V. I guess, is the V going to the bottom right? Is it pointing to the bottom right? I don't know. But it's called the Wild Duck Cluster, and it's a very pretty cluster. I highly recommend you take a look at this with any telescope, and even binoculars show this really well. Highly recommend that. So, and you can see our stars are not perfect points tonight, and largely because of this, the atmosphere is a little bit shaky. My focus may not be perfect, but we've seen a star cluster here. So that is what they call an open star cluster. Open meaning it's kind of big. And next comes a globular cluster, the Great Hercules cluster. This is one of the best in the sky. This is a ball of stars, about 100 to 200,000 of them. An amazing cluster of stars. It reminds me of a pile of diamonds on black velvet. And I just read another description. Somebody called it like an exploded firework, like fire, in the sky, fireworks. So, a frozen, exploded firework. So this is the Great Hercules cluster, and that is a lot of stars. Like I said, it's I think a couple 100,000. And if we zoom in, imagine if we lived around one of those suns there. Some say that we'd never have full dark night. We would no longer have night because there are so many other stars so close by. They'd be really, really bright at the nights, and so there's no night if you live in the middle of that. But we don't know if anybody lives there because it's about 22,000 light years away. So if they're going to get our signals, they still have to wait another 22,000 years, 21,850, or how many years have we been putting out radio signals? Or anyhow, it's hard to communicate. What's also interesting about these these globular clusters is sometimes you see patterns in them. See the dark lane there? It looks like there's some dark lines there. I don't know if it's an optical illusion or what. The human eye sees weird things in these things. So we've been cruising out into space. We started with the stars, like that star Vega, that's 25 light years away. And I didn't tell you, but those birthplaces of stars that we saw, all those red ones, those were all about 4,000 light years away, meaning the light took 4,000 years to get here. So that was way back at the beginning of civilization, right? At the beginning of civilization 5,000 years ago, the light left there on its trip here, and it's almost incomprehensible. Light took 5,000 years to get here? That's a long ways. But this one is 22,000 light years away, so it's pretty far across our Milky Way to get over to M13. So we've seen where stars are born. We've seen star clusters. The next stage is death. How do stars die? Well, if you got a star like the sun that's not very big, our sun is kind of average in every way, they don't die with a bang, they die with a whimper. So let's see a couple stars that are dying with a whimper. We're going to go to a dying star nebula. This is called the Ring Nebula, and this is where a star has puffed off its atmosphere into a shell, a bubble around it. And this bubble shell is expanding. And this bubble shell is hot. And it just slowly puffs this bubble bigger and bigger and bigger until the star just kind of dies and extinguishes like a candle. But along the way, that bubble gets bigger and bigger and hotter. And it's going to happen to our Earth, too. We're going to get enveloped by that bubble, and we're going to be toast, literally fried toast. And so the ring nebula is great because it's so colorful. I'll go crazy here and we'll zoom in. Like, as you can see, the view is getting better here. You know why the view is getting better? We're getting further away from the moon. I just want to comment on that. Let's look at the whole sky here. Moon down here. We're looking at Saturn and Jupiter. We're taking pictures of stuff down here. We're taking a picture of stuff that's near the moon, and also we have the smoke going on. The smoke scatters light and causes a big halo, a big fuzzy halo around it. So that's why our pictures down here were kind of crappy, in my opinion, certainly versus what I'm used to seeing. Good question by Marty. How accurately do we know the number of stars in M13, the Great Hercules cluster? Well, there's academic papers on that. They're not new. They're probably 30 years ago, and they actually, astronomers counted the stars in it. They would divide it into quadrants, right? They say, okay, in the upper right-hand quadrant, right, in this quadrant right here, there's X, and so we estimate we're seeing 1/8 of the entire sphere. So we'll multiply that times 8, right? So they count what they can see in a quadrant, multiply it times 8, and that gives you the total. And so yeah, they do a lot of research because they want to know what's the mass, what's the total mass, how much mass in each star, multiply it times a couple 100,000, get the total, and then they can do a model of its expansion. And so globular clusters are one of the most unknown objects that we really, they're kind of freakish. We don't know 100% on how they're formed. And it's weird if you imagine that the Milky Way is flat, right? The Milky Way is like a pancake or a frisbee. The globular clusters are not in the frisbee as much. They're up above and below. And why and how that is at least to me, it is not well known. Some people say they were like little miniature galaxies by themselves. But globular clusters are very unusual. And so thanks, Marty, for that question. So the Ring Nebula is fantastic. That star in the middle is puffing off its atmosphere, and this is a hot shell of gas. So imagine that on this scale, maybe Earth is inside the bubble. The orbit of the Earth is inside that bubble. Well, the bubble is hundreds and thousands of degrees. So when that happens to us in 2 billion years or whatever, the Earth's atmosphere will be boiled away, and all our life on Earth will be toast, literally. I think the different colors, again, refer to different types of gas. I'm not exactly sure what color, what refers to what, but you can see that it's really beautiful there. It has a lot of different structure. The gas is breaking up out here, but it's the shell is more intact in the top and the bottom. And this is a great object at astronomy at the beach, or anytime you're looking through a telescope. This is one of the coolest objects. You can see it even with light pollution in your backyard. It's really neat. But seeing that star in the middle is a tough observing challenge. I will tell you that I've spent many a night with people cranking up the power and trying to see that little guy in the middle, and that is a tough task. There's a galaxy nearby, and I'm just trying to see it. Oh, I think it's right here. Right here is a galaxy. Okay, now that everything else in this picture is in our galaxy, so they are relatively close to us. Well, this is way further away. That's a whole step change. Okay, the Ring Nebula is 2,000 light years away. So at the time of Christ, the light left the Ring Nebula on the way here. So it took 2,000 years to get here. So this is a dying star nebula. Let's take a picture of another one. And this next one, it's further along. It has expanded more. This is called the dumbbell. because of the shape. Some people said they saw the dumbbell. I don't know if you'll see the dumbbell shape, but you'll see definitely that it is larger and it's been expanding for more time. Keep the questions coming because we got this dead time right here. We're just staring at the numbers going up on the camera. And I will take requests as possible too. See how much bigger this is? Look at it. The ring is that big. The dumbbell is this big. Now the dumbbell is half as distance away. Or no, it's 1500 versus 2000. So it's a little closer, all right? But it's much bigger. And this star in the middle is the one that's dying, and it's puffing off this outer shell, and it's kind of football shaped, and it looks like the ends are blown out here. You can see the ends this side and this side, but then again it's got the nice shell on the top and the bottom. This is also a cool object in X-rays. They've taken this picture with professional telescopes with X-rays, and there's these huge explosive rays that are zapping up this way and this way and this way and out that way. So that's way cool. I'll go full frame for you just to kind of show you. This is what the whole frame looks like. The camera, this is a Canon camera, is 1 degree field of view up and down, and 1.5 degree left and right. So it's a pretty wide field for a remote control telescope. If I wanted to take pictures of just galaxies, because that's usually the pinnacle of astrophotography, a lot of people that's what they want to do, is take close-up pictures of far, far, far away galaxies. And to do that, you need a bigger telescope with a longer focal length. My goal is to be more of a generalist. I like to take a picture of everything, and so this works well for me because it's kind of a moderately sized telescope. But another thing I want to point out here is look at the difference in star colors. We have white stars, we have yellow stars, we got red stars. And this all has to do with how old they are and how hot they are. The red stars are older, they tend to be older, and they are cooler. And the whitish and even the bluish ones are hottest and youngest. So this is the dying stars. All right, so let's see. What about other ways a star can die? Well, there are stars that are bigger, and if they're bigger, they die more spectacularly. They die in a huge explosion, and the Veil Nebula is the remnant of a supernova. So supernovas are way cool to see because they are remnants of a star going kablamo a long, long time ago. And I think this one went kablamo 50,000 or 100,000 years ago. And we have more questions. Andromeda. Yes, we are going to go to Andromeda. That's going to be one of my last things because a tour of the universe, we go from near to far, and Andromeda is pretty far away. The Snowball Nebula. I think we might be able to do that. Yeah, we might be able to do the blue snowball. I think, yeah. So we'll do that next. Can you see all these tendrils and lightly it's very they call it the veil because it looks like a twisting semi transparent object. I'll go full frame on this thing. So the explosion happened in the upper left hand direction. This is a shock wave. The shock wave is circular. The shock wave is moving to the lower right. And this shock wave is gas moving at, I think it's something like 30 miles per second. It's expanding at 30 miles per second, and it's a star that blew up, and all of the material is just gone into tiny, tiny pieces, and it's getting just spread out through space. And as you know, we're made of star stuff, and it takes a star to make the heavier elements like iron that's in our bodies. And then when that iron is in the star, it dies and it blows up, and that iron is then redistributed throughout the solar system or through the universe in these supernovas here. And you can see a piece there is more bluish right there. You can see that. But yeah, these tendrils are very cool to see. But that's the. And let's see if we can make this a little better with this histogram. It's kind of hard. You can't do magic. The moon is going to do what the moon does, and the moon kind of hurts our view. I'll be doing more of these sessions now, and when the moon goes away here in about a week and a half, I'll do some, and you're gonna do a lot better to see objects like this. I can go longer exposure, and I can show more detail. So there was a request for the blue snowball, so we hit find targets. This is the program that runs the telescope. Blue, no data found. Okay. Let's look up snowball. Nope, there, but I'm not giving up. I remember that something around here. One of these dots. Oh, the Saturn. That's what. Yeah, the blue snowball is not available. I don't think it's available. Or if you can put it in the chat, you can tell me. Somebody can chat me. 7662. Well, let's do a Saturn first. It's next to the moon. It's going to really hurt us, but this one is just cool because we're gonna, and it really doesn't require much exposure. We'll turn it down to 17 seconds. This is a dying star that's gas bubble is shaped like Saturn. And then we'll put in 7662 in the program and see where that is. The camera is operating at 73 degrees, which is good. There it is, the Saturn Nebula. Isn't that wild? It's got this green bubble that it's puffing off, but there's two ends of it that are sticking out. So it's blasted gas, these like antenna on the side. I'm sure the professional astronomers know how this happened, but I have no idea how that would happen. That's just weird. But I'll go full screen, and you can see how fascinating these things are. They really stand out with their color there, this Saturn Nebula. Okay, so let's go over find targets, local catalog. Let's try NGC 7662 blue snowball. Oh, there it is. I was wrong. It's in Andromeda. Okay, so we hit go. There it goes. And if I'm watching my security camera on the telescope, I can see the moonlight reflecting off the you can see it move. See you can see the moonlight reflecting off the shiny tube. Although the tube is not as shiny as it normally is because I got a film of dust on it. The telescope needs dusting, a severe dusting and cleaning. But due to the plague, I haven't been able to get out there. I don't know when I'll be able to get out there. I need to do some maintenance, but hey, it's working, right? So we should be happy there. So, all right, blue snowball. There we go. Yeah, this Saturn one is just weird. I don't think I've taken a good picture of it. I need to take a long exposure of that. So I'm going to put that down as one of my to-do lists because I have an Instagram account and I put all my pictures on there. It's AstroPics Daily, ASTROPICS Daily, and I have 20,000 followers and I show all my pictures there. And there is the blue snowball. It's blue. Teal. It's teal. And again, this is one of those dying star nebulas. It's definitely different in color and in size and in shape. Really fun to hunt these things down. They're dying star nebulas. The astronomers in the 1800s called them planetary nebula because they kind of had a shape of a planet and the size. But it's a pretty poor name, if you ask me. I mean, I try not to use the name planetary nebula. I use the name dying star nebula because that's really what it is. It's a dying star. So we've been able to see 4 dying star nebulas tonight. We saw the Ring, the Dumbbell, the Saturn, and the blue snowball. And the cat's eye. Well, tell me what the NGC is on the cat's eye. We can try that. It's not too small. We can, as you can see, we can zoom in pretty good. But what's nice about the night sky is, you give it a little time and you get new stuff. Things will set in the west. It's the right-hand side here. This stuff is going down, and over here, this stuff's coming up. And you see now that Mars is higher. When we first saw it, it was just coming up, and now it's higher. Okay, 6543. I should remember that number. So, cat's eye. All right, let's. There we go. Cat's eye is in Draco. Looks like a snake, doesn't it? See the long snake and the head of the snake right there? That's Draco, which kind of wraps around the north celestial pole near the Little Dipper. So we are there. This is the cat's eye, and the cat's eye is really weird, and I think we're going to turn down the sensitivity here. Okay. Because it kind of looks like a cat's eye. It has that iris, I think the vertical iris, I think. And if you've got a telescope in a dark sky, you can spend the whole night looking at these things. There are hundreds of them, and each one's a little different. But you do need high power, and you need a very dark night, and also a hydrogen alpha filter. Okay, so that's the cat's eye. And we've totally overexposed it, as you can see. I mean, you can't see anything inside. So let's try to look inside. Let's just do a 5-second exposure, because we want to see that iris of the cat. In this picture here, you can see that I have a bad blue pixel right there. See that? If I zoom in, you can really see it. That's not a blue star. That's a bad pixel. Okay, now you're starting to see some interesting structure there, but look at, we are still overexposed. Let's go to 2-second exposure. But we got a beautiful green color there, and it looks brown at the bottom. Oh, there we go. Isn't that wild? That is just fascinating. And you can see the central star there. Yeah, well, thank you for suggesting that. And I'm not pronouncing your name right. Samir? Samir. But thank you. That's pretty awesome. Yeah, I have a... Let's see if I can... I'm going to try to pull up... I'm going to try to pull up a picture I have of that I might have that I took of it. I got the cat's paw. Oh no. It's 6543, right? Wow, I have never gotten a good picture of this. That's pretty cool. Well, that's another one to add to the list. Thank you. Yes, it's really a complex object, and like I said, this telescope I have is not a long focal length telescope, so it's hard for me to get really good pictures of small stuff. But as you can see, and also if I take many images, I can stack them up and get a sharper picture, kind of like the same as you're taking a picture of Saturn. But as we zoom out, you can see that that little guy is small, very small. If we go full frame, it's very tiny. But in the eyepiece, your eye immediately goes to it because it is different color. It's that shocking green color, and not many things in the sky are that shocking green color. So we have gone all around our Milky Way. We've gone all around. We've seen stars and clusters and nebulas, and so I think it's time to go to a different galaxy. So our tour of the universe goes out from stuff that is just 1,000 to 2,000 light years away. Let's go to 2 million. And somebody already mentioned this earlier. This is Andromeda Galaxy. We're going to go to Andromeda. This is our closest neighbor. It's 2.5 million light years away, which is mind-boggling. Can you imagine the light from that galaxy taking 2 million years to get to us? That's amazing. We'll do a nice long exposure, 45 seconds, because we're far away from the moon, hopefully. It won't be too washed out because I want to get a really good shot here. So now we've jumped from our galaxy to another one, and this is the furthest thing you can see with the naked eye. If you go out in a dark night, you can see Andromeda with your eye with no optical aid. I saw it just the other night, and it was amazing. Full frame. There we go. The galaxy occupies the whole field of view here. You can see the dark dust lanes, the nucleus where there's stars packed together. There's probably a black hole in the middle there, and it is home to what, 200 billion stars, 100 billion stars. It's got two companion galaxies that has captured in its tractor beam of gravity. This one right here, which is Messier 110, and this one right here, which is Messier 32. And this is a little elliptical galaxy that is old, and so it is way older than the Andromeda, and that has compressed. And I've been told that this right here is one of the brightest things that we know of, because it's far away, but it's all the light is concentrated into a small space there. Now, can we use our histogram to improve this? I'm going to see what I can do here. I'm trying to take that moonlight away. Yeah, it's a little better there. So you can see that it's huge, and it's of course it's bigger than my field of view right here. You know, for this this picture, because it's bigger than the full moon. Now, when I wanted to take a picture of this, I had to take pictures over the course of several evenings and to stitch them all together. And to do that, I got this shot here. So you may have seen this in the preview, but as you can see, that this took two. You can't see it, but I had to stitch together the top half for 3 nights and then the bottom half for 3 nights, and had to use programs like Photoshop to put the two together. This is a 2-panel mosaic, and this is about 20 hours of exposure total over a week. of work. And so it's possible to add up those photons. That's what this is. You're just adding up the photons and taking pictures over many nights, and that's the essence of it. We're really short-circuiting the process here by just taking these snapshots, but we're kind of having fun. We're just observing, just like you would with a telescope at Astronomy on the beach, right? You would just be pushing it around and looking at the sky. Let's see. There's another galaxy close by we might want to look at. The Pinwheel, M33. And this is another galaxy that's about 3 million light years away. Mars is getting higher, but not high enough to see yet, unfortunately. We might even not be able to see this. The program here tells me that it's at altitude of 24 degrees, and the roof is about 24 degrees up. So we may not be. This may be a picture of the roof, and the roof is dark. This got the moonlight on it, but you're not going to see a whole lot of detail. Okay, let's go back. Oh yeah, I think the red is the roof. I think that's the edge of the roof. So the galaxy is just clearing the roof, but you can see you could basically see what the pinwheel. See that it's got the nice spiral arms. It's a nice pinwheel. You can see that it's rotating because galaxies rotate. So the pinwheel is kind of pretty, but I think we've been trying to do it. We were a little bit too early to try to get a shot of it. All right, so unless there is a request, I'm going to go to an extreme object. This is the furthest thing that I've ever taken a picture of. It is more than halfway to the beginning of time. This is a picture of a quasar. It's called Einstein's Cross. It's a gravitationally lensed quasar. What I'm trying to do here is extreme. It may not work. We may not see anything, but hey, nothing ventured, nothing gained. Let's give it a try. So I'm going to type in the object that is near, PGC 69457. Okay. We're going to take a 40. We're going to really crank up the speed. 45 seconds, 6400. Okay. Let me show you what we're trying to look at. Einstein's Cross. This right here. A quasar is a quasi-stellar object. It is a very, very active galaxy that is very bright, and so therefore you can see it far away. It is so far away that we really can't see it directly, but there's a galaxy in between us and them, and that galaxy is causing us to bend the light into these 4 dots. The galaxy's in the middle, and the quasar is way behind it. So the galaxy is bending the light into 4 beams. It's splitting the light into 4 beams, and it's blasting those at us. Otherwise, we would not see it. So it's called gravitational lensing. It's something that Einstein had predicted, and that's why they call this Einstein's Cross. The galaxy is hundreds of millions of light years away, but the quasar, these dots, are 8 billion light years away. And as you know, the age of the universe is 14, so we are 8 out of 14. We are very close to looking back to the beginning of time. And I may have overexposed this thing, but I know from previous experience where to look. It's this dot right here. Okay, so it's not very impressive, right? But you're looking at something that is 8 billion light years away. So it's not very often that you might see something that far. You'll never see anything further away unless you are doing a lot of observing. So I had done this for the first time earlier this week, and it was the furthest thing I took a picture of ever. So that is Einstein's cross. What we're seeing is, I'll go back to the picture. This was taken with a professional telescope, and so we can't get that level of magnification. So I'm looking at this same thing, but we can't zoom in enough to get that detail. So sorry, we're not going to get any more detail, but that's it. That's Einstein's cross right there. And so it's pretty close to the moon. And so yeah, we're look how close to the moon we are. So this is a very extreme observing challenge that we gave ourselves tonight. So we did pretty good. We saw it, but not much detail to it. So I was impressed by it when I first saw it earlier this week, and it was kind of fun. And please, if there's any more requests, I will try to hit them. But otherwise, I want to wrap it up because it's 11:20 here in Michigan, and all right, somebody missed Jupiter, so let's go back to Jupiter. Jupiter is fun and easy, so yeah, let's go back to Jupiter. Let's observe Jupiter. Hopefully our focus is still good. If it's not, we can fix our focus. And then we're going to, Mars. We got to get to Mars before the end of the night. Okay, so we're going to put it on live video. Boom, 5x, boom, 10x. So there you go. You're seeing Jupiter's moons right there. And as you can see, these two inner ones are bigger than that one. I think that's Ganymede, Callisto, Europa. And Io is not there, meaning Io is either in front of or behind Jupiter. And Io is... it always stays very close to Jupiter. So that's the video. Let's take a still shot of it. And as you saw before, it seemed like we needed like, was it like 100th of a second? Let's put it on a 40th of a second. Let's just take a shot here. Too much. So you can either make a shorter exposure, or you can turn on the sensitivity. So I'll turn on the sensitivity down to way down to 100. Okay, so we're starting to get some of those, but still we're not seeing those beautiful cloud bands which are move in the left-right direction. Those horizontal cloud bands. Also, you can see, can you see that just like me, Jupiter is fat in the middle, fat at the waist? See, Jupiter rotates so fast that it is fat at the waist. That's how Jupiter works, and it rotates so fast that it rips its clouds into horizontal lines. So Jupiter is really fascinating from that standpoint, and I think we're seeing the orange-red spot. See that right there? I think on that corner we're seeing the red spot. What I can do, I think that's probably the best we're going to do, but let's see if we try a shorter exposure and more sensitivity. Now, other people in my lowbrows club are much better than I am at taking these types of pictures, and so it's kind of amazing that a fancy telescope like this doesn't take good pictures of the planets. It's set up to take pictures of stuff that's far, 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 far away. and so it's not going to work for really close things. So that's going to be our last shot here. Yep, you can see the dark lines. That's Jupiter. All right, let's not give up on Mars. We're going to click on Mars right here. It's only 13 degrees up. It's just not high enough to see. I'm sorry. Not going to see it. Very sorry about that. No Mars, but to be honest, it's going to be half of the size of this. Okay? And so it's going to be hard to see any of the canals or the little green men. We're just not going to see them. You need a really good telescope to see the aliens, or maybe the robots, or Matt Damon. We're not going to see Matt Damon on Mars very easy either. So sorry about that. Looks like Mars is not good for another hour, really. But if you pay attention or subscribe to my channel, watch my YouTube or watch my Instagram, over the next month, I guarantee I'll have good pictures of Mars, and we'll do live observing, because Mars is not at its closest point. I think that happens in early October. So Mars is still getting better and better and better. So we'll be able to get a shot of that later. So if there is nothing else, I don't see any other requests. We're going to shut her down, and I appreciate everybody hanging in. Thank you so much. It's been a good time. Oh, tomorrow night I'm going to do basically the same thing. So if you've got requests, or come up with requests, between now and tomorrow night, we're going to give another shot. And we'll be doing much the same thing, but I'm happy to do special requests. So work on that, and I will sign out, and thank you very much. And I'll show some pictures that I took, and you'll also see how to see my Instagram pictures. So thank you everybody, and watch the other Astronomy at the Beach presentations. You're going to see them tomorrow, starting at, I believe, 4 p.m. And on the website, there's also a customer satisfaction survey that I put together, and please take the survey and tell us what you think, because we want to try to do a better job next year, even though we'll probably be not virtual, but we still might be some virtual too. We might keep this going, but also have the telescopes out there at Island Lake State Park. So I hope to see you out there next year.